I'll lead over to our guest speaker this morning. It's a pleasure. You have seen the EPFL, the French university, or the Swiss French university, obviously, on one of the slides. And it's one of the most dynamic places. And there's a lot of challenges in the university world, how people learn, the new generations. And it's a pleasure that we have here the Vice President of Academic Affairs from the EPFL in Lausanne, Professor Dr. Philippe Gillet. Welcome to NIDays. Hello.
Hello.
Yes.
Okay. So thank you very much for the invitation. You have already seen that we have a lot of interactions with national instruments for research. You saw one of these applications we have with you on trying to set up a grid on our campus. But we have also a lot of interactions concerning teaching. But before starting my presentation, just a few figures on EPFL. So as it was mentioned, we are the French-speaking Technical University of Switzerland. We are a research institution. We have 10,000 students. 50% of them are foreigners. We have 350 faculty. 2/3 of them are foreigners. They are coming from all over the world. And we have 3 missions. The first one is to train at the highest level engineers and researchers. We have also to do the best research we can do, both on the very fundamental side, but also on the more practical side of research. And finally, we have also to do outreach. And one of our major roles is also to bring what we are discovering to the market. And we are trying to do these 3 missions as well as we can. So today, my subject is to show you that even if you are a very good university in terms of research, today, if you want to belong to the leaders group of universities, you must also be a very good teaching institution, because the two are intimately connected today. And to stay at the forefront of education, it's like research. You need to always evolve and try to fit to what is going outside your own institution, because we are in a globalized world. So there are new paradigms in research, in companies, as we've seen today, but there are also new paradigms in education. Why? Because the kids that are entering in our universities, they change very rapidly. 30 years ago, it was not necessary to adapt teaching, I would say, every year. Today, it's completely changing. We have to continuously adapt our teaching because the generations of students we have in our universities are connected people. They belong to this well-known Y generation, and this, as we have seen in your company, everything is connected. Our students are connected. They do not have the same competencies, skills that we had before 30 years ago or 20 years ago or even 10 years ago. So they have access to every information. They have access to everything today. They do not wear watches, but they have their iPhones on which they can find everything. So knowledge is worldwide, and we have to adapt our training to this generation. And we have also new challenges to address. Because everything being global, everything becomes complex, and it implies new generation of engineers, for instance, who are more interdisciplinary in their approaches. And we have to adapt to new developments more rapidly than, for instance, I had to do when I was a student. We have also to face a globalized environment, which is changing a lot. In our countries, in the developed countries, we are facing an engineer shortage. And this is crucial for the future development of our countries. And if you see to this report from the UNESCO, you see that today what is urgently needed in our countries, but also in the developing countries, is to increase the number of engineers. But this is very difficult, I can tell you. For us, it's every year we have to fight to get the best scientifically trained students to enter EPFL. It's not an easy task, so you have to fight, because many of the kids are now moving to other disciplines, more soft skill disciplines and so on. So it's very difficult today to attract engineers and scientists. And this is not only a challenge for us, but also a challenge for the emerging countries. But there is a second aspect in this globalized world. We are not alone. And there are few newcomers who are becoming big players. Just a number. In Switzerland, we are training every year, I would say, a few thousand engineers. China today is training more than 1.5 million engineers. And these people are more and more well-trained, and I can tell you they are very innovative. You were in China, I suppose you can tell us that they are very innovative today. So this is the global context in which we have to adapt our training, our education. So how do we meet these challenges? First of all, we try to reinforce students' awareness of the new challenges. For instance, this year, every freshman has a course on what we call the global issues, because they will have to solve all these global issues we are facing, for instance, climate change, food supply, communication, revolutions, and this is not only technology. This is also something you have to do with soft skills. They must understand the world in which they are living, and they must be trained for that. It's not obvious to understand the world in which you're living today. So beside this training for science and engineering, we have decided to reinforce the social sciences aspect of their future jobs. So this year, every freshman has this new introductory course on global issues. Then it's very important also to be at the forefront of knowledge. So we try also to reinforce the expertise of our students in very specific fields, mechanical engineering, biotechnology, etc. So they have a very up-to-date training in very specific fields. And finally, this is done by doing both up-to-date courses, ex-cathedra courses, but also we try to train them using hands-on work or practical work. And finally, what is probably the most important, because we saw it in your presentation, Alex, is that they need to be interdisciplinary. This is very important. You cannot use an iPhone. An iPhone is an integration. I have counted the number of Nobel Prizes who are embedded in an iPhone. There are more than 20 Nobel Prizes that are embedded in an iPhone. If you put a piece of Einstein, a piece of Broglie, of de Broglie, etc., you have 20 of these people are embedded in an iPhone. And this is something you need to know if you want to understand this kind of technologies you are using. So it must be an interdisciplinary training in the end. So just to summarize, they are trained because they have to solve issues. They will work to solve issues, global issues today. So they need to be aware of these issues. This is done in the first year, but also in some other years. They need to be very good in their disciplinary fields. And finally, they need also to learn what is happening in the other fields in which they will with which they will interact in the future. So this is becoming very complex to do. We are also facing revolution. I don't know if you're aware of this acronym named MOOC. Everybody knows a MOOC? What a MOOC is? Who knows? It's like the watch. There are a few of them. So MOOC means Massive Open Online Courses. This is some sort of tsunami we have faced 2 or 3 years ago. During his career, usually a faculty like me, okay, sees 10,000 students. Today, one single prof in 1 year can be in contact with 100,000 students. And this is a big revolution. This graph on the right-hand side just gives you the number of students that 10 EPFL professors have been in contact with during last year. Every year we have 1,000 students at EPFL, newcomers. 265,000 students. And this is due to what we call this MOOC revolution. So what is a MOOC? It's fundamentally nothing new. This is what we called e-learning 10 years ago or 20 years ago, and you see all these different names we used in the past to characterize the use of, I would say, computer-related teaching. And you have, I don't know if you know them, but computer-mediated learning, online education, e-learning, open learning, etc., etc. But now it's massive, open online courses. Nothing fundamentally new, but in fall 2011, everything started at Stanford, big place. Two profs, Chun and Norvig, have decided to launch their courses on the web. And they were extremely surprised because when they got 160,000 students connected to their lectures. And it was a course on artificial intelligence. 22,000 of the students completed the course, 420 perfect scores, but none of Stanford. I remember that the fees in Stanford are a bit high, and this is something which was extremely surprising. And many of these people having these perfect scores were from very isolated places throughout the world. This was the first, I would say, shock related to the MOOCs. Why are they massive? They are massive because of this technological breakthrough, especially the tablets, which became very cheap, which became very easy to handle, thanks to the broadband of the internet, to the cloud computing also, but also to the fact that the kids are now working in a world where they are networking through the web. So you have a lot of social networking around the web, which permits communication and interaction between people. And finally, we have this wide generation, which is addicted to this kind of support. Key features. It is open access. The content is freely accessible. Personalization. These are short videos. Briefly speaking, a MOOC is a YouTube sequence with exercises, quiz, and a social Facebook-like network surrounding the whole. This is a MOOC. And so you have segmentation. It's very short, in very short videos, because today the kids, their attention is 4 minutes. They cannot do something focused for more than 4 minutes. 20 years ago, it was 12 minutes. But okay, they can do 3 things at the same time. Okay, you do the same. So some of you are just using your iPhones while listening to me, etc. That is the new generation. So this is also another very important point, is that you can adapt the learning speed. So in fact, you can stop the prof, because it's a video. You cannot do it in a classroom. But here, you cannot stop me. Or you, okay. Don't stop me. So, but in a MOOC, you can stop the prof. So if you do not understand what he just said, you can stop, reward, and re-listen. So you can learn at your own pace. This is something very important. Finally, you can also use the fact that it is massive to do peer grading. And we have done a lot of experiments at EPFL just to show that the students are even better than the prof for grading their colleagues. So you can do massive grading using those who are following the courses. This is a lot of things you can do with these MOOCs. This is why it is a revolution today. Okay, there are a few front runners. Today there are 2 platforms. There are 2 US platforms. There are a lot of other platforms coming in, but the 2 first platforms were launched for these MOOCs are 2 US platforms. The first one was Coursera. We are on both of them. Coursera was launched by Stanford and Caltech, and the second one, which is edX, was launched by MIT and Harvard. So these are the 2 leaders, and today you can see that there are more than 600 courses on Coursera. I think there are close to 1,000 courses now, which are free. So everybody can connect to these courses, follow the whole course, get a grade, and finally, perhaps in a couple of years, a diploma from such training. So what does it imply for teaching in a university? So you can use them as some sort of additional book, some sort of a book. You can ask your students to use these MOOCs as a book. Then you remain in some sort of status quo state in which you have the lectures which are given by these MOOCs, but they are given on campus, and then you go to the exercise classroom, and finally you do your homework, and so you have a classical sequence of teaching. But there are other sequences which are possible. We can use what we call the flipped classroom. So you decide that you force your students to do more personal work. So you suppress the lectures on campus. You do them through the MOOC system. And so lectures is the responsibility of the student. They have to follow the lectures, and they can do the exercises on campus. So you work in more smaller groups. You have more interactions between the students and the prof. And finally, they do their homework, and then they go back and forth through the system. This is what we call the flipped classroom. And finally, you can try to do everything online. But that's not easy for all fields. So in math, you can imagine you can do math completely by a MOOC system, but it's more difficult to do it, for instance, for physics, for instance, in which you have to do experiments. But we will see that even when you do applied physics, you can imagine that in the future, we will be able, thanks to National Instruments, for instance, to do it completely online. We have already some examples in which we can show that you can do a complete training through a completely remote system in which you have the lectures and you have the practical work online. Product, this is the new amphitheater. This is the new classroom. So the prof is just behind a camera, and everything is recorded. He has a tablet. He's writing everything on his tablet. He's bringing his illustrations. He's exercising. Everything is done through a production system, which is design, record, review, edit, check, and publish. So everything. So we have 5 of these setups at EPFL to record online courses. The first one at EPFL was this guy, this professor, Martin Odersky, which is the inventor of an informatic language you probably know, which is Scala, which is, you know Scala? Who knows Scala? I will tell him. There are only a few. Because every time you send a tweet, you're using Scala. So many, I think all of you then are Scala users, because it's a language that is used by Twitter, for instance. But it's something which is an evolution of Java. And it's one of the competing language. Scala versus Java is today something which is, I would say, affecting the world of computer languages. He started, this guy had a course at EPFL with 200 students in his classroom. When he started, he had more than 50,000 students registered for his course. And it's now the 3rd year he's proposing the course, and the number of students is increasing every year. Today at EPFL, in a 1.5 years, we have produced more than 20 courses. We have 13 in the pipe. I would say in a couple of years from now, we probably have 200 online courses, both in French and in English. Today, 40,000 students are connected to our courses. But this is one part of the revolution. The other one for us is to come back to more practical work. With Pascal Viomnet, which here in the room, we have decided to completely refurbish our hands-on training at EPFL. So we have introduced the concept of teaching satellites, in which the students will be trained in their different disciplines. For instance, in engineering, we have decided to refurbish completely our setup. We have a lot of new benches coming from your company, in which we try to train our students in electronics, in sensors, actuators, systems, and so on. But these are brand new specific rooms in which the students are going through during their curricula. We have also a plan to develop a molecular satellite in which we will try to make the interaction between chemistry, biology, biochemistry, biotechnology, in which the students will also be trained. This is in another place of the campus. We have also a material science satellite, which is currently under progress, in which the students will be able to use a lot of different techniques to test materials, just to do it with their hands, just to understand what are the basic properties of materials. And everything is open. We are planning to have a prototyping place where the students can come to use mechanical and electronical workshops just to implement what they have prepared during their exercise sessions or during the ex-cathedra courses. We have also in plan to have these physics, chemical engineering, and informatics satellites. The ultimate goal for us is to have them open 20 hours a day and all the days of the year, but this is a target which is difficult to reach in the coming years because it's extremely costly to do that. Remote hand-on teaching, that's something on which we perhaps should work together with you, National Instrument, because this is something which needs to be connected to the MOOCs. And there is a lot of room for improvement to have this complete sequence of online teaching, including the hands-on job. Today we have a few already existing experiments on that. We have, this is for instance a system in which the students can control remotely a mechanical system and try to find, for instance, equilibrium features in a mechanical system, but they can do it through the web. So this is something we have developed in one of our labs, and this is open 24 hours a day, 7 days a week. But we are also thinking on new large-scale experiments. You mentioned the grid system we have at EPFL. This is more for research today, but in the future it could be also used as a testing bed for the students. For instance, in one of our brand new buildings, we have equipped everything to do local monitoring. So we have, on the ground floor, we have a lot of optical fibers that are everywhere on the floor that permits you to monitor a lot of things, including loading, the stress and strain you're applying to a ground floor. But we have also cameras which are filming everything, every movement, so you can also try to think on the way the building is used. So the building itself becomes practical work for the students. And you have all the online data, so you can do ongoing monitoring of what is happening in your building, and this can be used by the students. We have also decided to develop the interdisciplinary skills of our students, and the idea is to give them opportunity to work on open-ended projects, to work in team, and also to develop these management skills. Because when you have a project, you need to be, I would say, ordered. You need to do things in a given sequence. And these are kind of things you need to learn, because it's not obvious. When you have, for instance, to do a robot contest, when you have to do a hydro contest. So for instance, this is an international competition in which we design and develop an energy efficient boat. But this is, it's a one-year contest, and so you have to be very pragmatic. You need to have these managerial skills to bring the final product to the contest. We have this solar decathlon contest, which is a huge contest in which you have to build a complete building which is energy efficient, and this is 2 years of work for the students, and you need physicists, mathematicians, informaticians, you need people coming from material sciences, so this brings everybody around the single project. And finally, we have this, as a last example, this lab in a tube experiment in which this is an EPFL internal competition. So how can we develop flexible sensors for physiological monitoring? You mentioned the iPhones, but today we have people who are developing synthetic skins, which are full of sensors, which are monitoring everything, your blood pressure, your heartbeat, even we have sensors which are under-skin sensors, which are monitoring the proteins in your blood, just to see if you are in good health or not, etc. So these are kind of things that are developed in the labs, but are also developed with the students. And this is something very stimulating for our students. So all these facilities, we try to have them on campus. It's a lot of investment for us. For instance, just working on this very small boat uses different places on the campus. So you need also to have a very good organization to finally do this kind of projects. And my last part is, I would say, a more different one. We have also the responsibility to help the developing countries, especially in research and higher education. 3 years ago, we created a network of engineering schools named RECIF, in which we have 14 French-speaking universities from 11 different countries, 7 from the north, 7 from the south. So you see the names. EPFL is one of them. And the goal is to develop a new concept of interaction with these developing countries. The idea is to do what we are doing, because they need absolutely the same tools, and they have absolutely the same needs than the one we have. So we do research and cooperation. The idea is to have joint labs with them, in which we develop what we call essential technologies, and these essential technologies are robust technologies for their major needs: access to energy, access to water, access to food in a safe way. And this is very difficult, I can tell you, to develop these kind of technologies. For instance, having a robust iPhone, it's very difficult to have. Something which is able to sustain very large temperature differences, which needs to be robust against shocks, etc. It's not very easy to develop, and it must be less costly than it is today in our own countries. This is the second pillar. And the third one is teaching, because these people need also a lot of teaching. For instance, in Africa, the market of education in Africa is like the market of everything. It's a huge market. And we need to help them to develop their market. So we have decided to launch with them teaching beyond our own campus, and we try to reach foreign students thanks to the MOOCs and to remote hands-on courses, but also to do local development of practical work. Just an example. We have, 10 years ago, our teaching technique was to send 2 of our profs for 2 months in Africa, moving from one place to the other to give lectures and practical work to African students. Today, with the MOOCs, things become completely different, because you can use MOOCs to teach much more people than we did before. And today, for instance, in this course on understanding microcontrollers, we have the MOOCs, which are done through the web, locally and through the web. And we have also, I don't know, do you see this? These are trainings that are done on-site, locally, in which they use their own microcontrollers without having the prof from EPFL in their classroom. The prof from EPFL is completely remotely connected to them, and he's just organizing the practical work with the students after they had the MOOCs through the web. So the lectures are given through the web, and the online education is also used to do the practical work there. And this, I can tell you, is a big market for everybody, not only a market in terms of money, but also a market in terms of intellectual input. And it's, I can tell you, something which is urgently needed by these countries. So I hope I've not been too boring for you. This is the end of my presentation, and thank you again very much for your invitation. Thank you very much.